Hello friends, it's me again, Dr. Patterson. In this video I'm going to build the circuit for week 3 lab, which we're focusing on potentiometer. We're throwing in a force sensitive resistor, servo, and then also using the potentiometers on the Mechaiddqd simulator, robot arm simulator, and also the servos on the Mechaiddqd simulator. So first circuit is going to be, we're just going to hook up the potentiometer, which, if you remember, we've got 5 volts. We have a resistor or something that looks like a resistor. And then we go to ground or 0 volts. And what we have with the potentiometer is essentially like a wiper. It goes from one end of the potentiometer to the other. And so the symbol for that is just like an arrow pointing at it, so it can move up and down. And what we're going to do is hook that up to one of the pins. And this time, let's use A0 for the potentiometer. Let's look over yonder. 1 second. And hook up the potentiometer. What I'm going to do, instead of using the rat's nest wires that we all have, I'm going to use some from a wiring kit that I have, just so that it's easier to see for you guys. So what I'm going to do first is start with 5 volts and ground. So I'm going to grab, the wire just fell in my keyboard. All right, I'm going to grab 5 volts and go straight over to the red line, the red column. And then I'm going to grab another wire and go from ground to ground on the board. And then I need a potentiometer. And it doesn't matter which way you turn it. One side's going to be 5 volts, the other side's going to be ground. It's a variable resistor either way you place it. You put it down here. And then I'm going to put ground into one side, just like that. And then 5 volts into the other side. And then the pin right in the middle, now I'm going to add back to the rat's nest. I'm going to go from A0, actually I can do better than that. Again, wire kits on Amazon, you can find them cheaper than Amazon, but on Amazon are typically like 10 bucks. And they make it look like much less of a nightmare. You can try to save them, but then they all end up looking like this, or it's like bent. Grab A0, and then we'll just go right over to that middle pin. Right? Hopefully already easier to follow than the ones in my last video. So we've got a potentiometer. Now we should test this and make sure it works, because that's what we do. Go over, still got the lecture code on here. But we just want to print out that value, let's say. So we've got an Arduino object. Let's start from scratch. Clearing and closing everything. We'll create a new Arduino object, calling Arduino command. Don't need any arguments because it's the genuine Arduino. If you have a knockoff board, specify the COM port and the type of board. So if we wanted to, I could go down here and say serial list. I believe, oh, it's not plugged in. Let's plug it in. Perfect example. Now I can type serial list again, and COM4 showed up, so I know it's COM4. And then I need to specify the board type, which in this case is just Uno. So I've got an Arduino object now, and I can even Add the semicolon because we don't need to print out everything there. And then I just want to read the potentiometer value, make sure that I have it wired up correctly. So I can say while true, or even better yet, let's do it for an amount of time because we don't care to watch it forever. While talk is less than 5, and we'll start a timer beforehand, so tick, and then the condition it's watching is making sure that the timer is less than 5 seconds. And inside of here we can say, hey, Arduino object, read voltage, and pass it. All we need is one argument, the pin number, which in this case was A0. And we can set it equal to a variable if we wanted to. We'll say volts again. It passes back a single value, which is the voltage that it's reading. Let's run that. Sit and wait for up to 1 minute. Hey, that was fast. All right, so as I was changing it, we saw the values change. Wired up correctly. I was surprised that it started at 0, but I did have it cranked all the way to one side. So we've got that. Now we wanted to wire up if we go to the lab tasks, we need for the second task, we need the force sensitive resistor, which again is the polymer sandwiched in between two kind of like squiggly conductors. I think I had said it was foam previously. It's actually a polymer. Well, I guess some foams could be polymers. It's like the square versus rectangle. So for this one, we need to, I put that in the board. We need a pull down resistor, just like we did last time. So the way that we're going to wire this up is, again, 5 volts. I don't know why I keep drawing the side like that. And then here, the force sensitive resistor, if I remember correctly, we go like that, the line through it and put an F next to it. We're going to draw a little dot right here and draw over. We're going to measure right there, but then we're going to also tie this to ground, if OneNote lets me. I never do the right number of squiggles. And we're going to use for this one, I think what we stumbled on last time was that the 330 ohm resistor was a better choice, because then we got essentially the full range from 0 volts, or very close to 0 volts, all the way up to almost 5, and I wasn't strong enough to make it 5 volts. So let's find a 330 ohm, which should be orange, brown. Second guessing myself again. We'll go with it. So we've got the force sensitive resistor in there. Let's add, let me switch cameras here. Let's add in a line from 5 volts. And then we want to add in a resistor, and I'm just going to go from one line down to the next. Maybe not. These legs don't cooperate. We'll go 2 lines down because I can't get it to bend that way. So now we go down a little bit. Let's see if I can bend this so you guys can see. Kind of. And then we need to tie that end, the other end of the resistor, just like in the diagram, which I can't get to unless I switch cameras, down to ground. So if we add another wire here, this one's probably going to be too short. Nope, it's going to work. All right, so now we've got it tied to ground. Now that middle pin, we need to tie to a pin. In this case, we'll say A1 for the force sensitive resistor. So we'll grab something better than a rat's nest wire. Let's use a different color this time. Orange. And we'll go from that shared row between the resistor and the FSR to A1. All right. Checks out, makes sense. Now, what can we do to test that? Well, all we need to do is change this to a 1 instead of the, well, we could read both and print them both out, right? Let's do that. So we can say, instead of volts, let's say FSR. And for, nope, that's the potentiometer. We'll say pot. And then FSR is equal to Arduino object dot read voltage and pass at A1 instead of A0. And then we can display, does it let me concatenate strings? I don't remember. Potentiometer. We'll pass it pot value and FSR. Maybe. Let's see if it works. Can't remember if you can add strings inside of the display function. Yes, you can. Squeeze the FSR and it goes up. Let's go a little more than 5 seconds. So we'll change the potentiometer, press on the FSR. Only getting up to 2. Interesting. Did I grab the wrong resistor? Get my resistor calculator out. 1 second. I made a mistake. It was not the 330 ohm. Which makes sense if we think about this for more than a second. It was the 10K ohm. Oh, 1 second. You guys didn't have to watch me sneeze. All right. So it was the 10K ohm resistor, which makes more sense because if we have the lower resistance value of the 330 down at the bottom, and then we're squeezing that force sensitive resistor and it's reducing its resistance when we do that, it gets down to a certain value and it can't get any lower, right? Apparently right around 330 volt or ohms is what we get because it was getting up to roughly 2.5 volts. And so we were literally splitting like the resistance from top to bottom and measuring right in the middle in terms of voltage. But with the 10K ohm resistor, we're still tied to ground. And when there's no force applied to that force sensitive resistor, it's much higher in resistance than the 10K ohm resistor. And then when we start squeezing it, it drops down, like I said, almost to 330 ohms. And so we're at that point with that much smaller resistance for the force sensitive resistor, we're much closer to that 5 volts. It's essentially like thinking about it like a potentiometer in that we're moving, when we're squeezing the force sensitive resistor, we're moving that wiper closer to the 5 volt side. And so the resistance between 5 volts and our measurement pin is lower. So now that we've done that, I can go back and show you that it does indeed correct the values. So the resistor is the 10K ohm, which is the brown, black, orange. I had them sitting in a pile with a bunch of other resistors. Don't do that because then you need a calculator to tell you which value they are. So when I squeeze on this, it gets upward, almost up to 5 volts. Again, I don't have diamond hands, so I can't get up to that. All right, 4.82 roughly, all right. So now we have everything that we need for the first two, except we don't have a servo. So what does a servo look like? Find my mouse. Let's go back down here. The servo essentially looks like a servo. We have a little arm that comes off of here. And out of here, we have 3 pins. We have, for us, it's 5 volts and ground. You might see VCC as the top one. And this middle one is the signal. And so what we're going to do is then tie 5 volts to, surprise, 5 volts, and ground to, again, surprise, ground. And then the signal, we're going to go to, in the lecture I did D6, let's actually go to D3, which is the lowest number for PWM capable pins. So if we go back over to me attempting to wire, we will take the servo. Oh, you guys can't see, for some reason the video stopped. 1 second. All right, lots of technical issues this time around. So we've got a servo, and out of here is 3 wires. So black is ground, red is 5 volts, and white is the signal. And so what I'm going to suggest you do, sometimes it comes with like extended pins to go into the board. Let's see if they gave us those. If they were nice, they gave them to me. Negative. Not that I could find anyway. So what we're going to do instead is take a red wire, one of the rat's nest wires, red wire to the middle, just plug it in just like that, and then to 5 volts, we're going to grab a green or a black wire and plug it in and go to ground. And when you plug those 2 in, you might hear it move a little bit. That's snapping essentially to like no signal, which is 0 degrees for the servo. And then we need 1 more. We'll go with yellow here. And we will I'll plug it into the board. I don't need to. Why don't we just plug it into, I said D3. So let's plug it into D3 instead of routing it to another cable. We'll plug it into D3, and then we will make this visible. Maybe. This is what double-sided tape is for. We'll just go like there. All right, I tried. We've got it on there now, and so we've got it hopefully wired up correctly. Now we can go back and say, well, how can we control that? Well, I kind of already inadvertently showed you the first lab task that I made during the lecture. But what we can do is say we're reading from the potentiometer and the force-sensitive resistor. Let's just write the potentiometer value. And again, if we go back to the documentation page for the servo, let's go back. For servo, you're creating a new object. So out here, right at the beginning, we just want to create this once. We're going to say my servo object is equal to servo. And then we need to pass it 2 things. One is the Arduino object that we've created. And then the second is the pin number that it's hooked up to. So in this case, D3. And that has to be one of the PWM capable pins. So we've now got the Arduino object and the pin number. And I'm not going to comment that, or I'm not going to prevent the output of what that is, because let's take a look at it once it prints it out. And then I want to write to it, but let's just do that and see what it prints out for us while I print out these values, which is gonna kill my, let's stop that. And then go back up and say, so it's passing back a servo object with properties and it saves the pin number. So for that servo, we don't need to specify the pin number anymore. It holds on to it for us. And so when we go to write a position, which is one of the two main methods on that servo or functions, we can just pass it the position, because at least I'm going to call it as a method on the servo object. If you want to call it as a function, you need to specify the servo. So there's two ways we can do this. We can write, we can say, hey, servo object, which is what I'm a fan of, if you can't tell. Hey, servo object, I want you to write a position, and then I need to pass it a value to it. And in this case, I'm going to pass it the pot value. And with the servo, we can only have a value from 0 to 1. And so we need to make sure that we're scaling that appropriately. If we write outside of that 0 to 1 range, we're going to get a warning that it was out of the range and it's only writing to, if you're below 0, it writes to 0. If you're above 1, it writes to 1. So we'll say pot divided by 5. And now that'll give us a value because we have a read a voltage between 0 and 5. We'll get a servo position between 0 and 1. The other way we could have written this was write position. Let's comment it. Write position, and then pass up the servo object, and then the pot divided by 5. Again, I'm a fan of using it as a object and there being methods that your actions that you can call on it. So we've got telling it to write a position and passing it the pot or the potentiometer value divided by 5, and then it's writing that. And if we wanted to, we could even say potentiometer and FSR and servo position, and we'd say, in this case, in these parentheses, pot divided by 5. So let's print it, or let's run that. Hey. So as I'm turning the potentiometer, oh, it stopped. I should know myself better. I talk for longer than 10 seconds, even though I claim not to. So once it starts running, we can use the potentiometer to control servo. Apparently made lab task 1 a little too easy because that's how we can test it out too. So you can see as I get down to 0, it's on all the way on one side. And then at 1, it's at the 180 degrees from there. So now we've got everything tested. This is everything that you need for the lab in terms of hardware. I will show you the Mechaiddqd software too. Seconds later for you, hours later for me. I realized I forgot to add the documentation to my website. So now when you go to the Mechaiddqd website, it's not just the documentation for Mechaiddqd. Down at the bottom, there's also functionality for the servos in Mechaiddqd. Okay, so once we've launched Mechaiddqd, what we're going to be focusing on for weeks 3 and part of 4 is, yeah, it's showing up, right, the robot arm simulator. So if we click on that, what it is in the lab, in the physical lab, we have, hopefully you could hear that, the physical lab, we have a robot arm and it's 5 servos. And that's the solid one that you see, the one you can't actually see through. In that one, there's one at the waist, so the whole thing rotates. There's one at the joint right above that, the shoulder, that will rotate front to back. There's one at the elbow, which does 180 as well, one at the wrist, and then the grippers close as well. So that's what you're seeing over on the right-hand side. On the left-hand side, after running this lab for a couple of years, I said there's got to be a better way than what we were doing, which was guessing and checking on the values that were to be written. And so I looked at what commercial software does, and they always have some type of simulator to go along with it, their hardware. And so I said, let's make a simulator, but also a joystick, which there are commercial options out there where it's literally you're like manipulating a small scale version of it. And so we went with that, and I said, well, I can do the simulator, and I can also do this hardware, which I made a laser cut version out of. It was made out of medium density fiberboard, and at each joint, it was approximately the same size as the actual servo arm. At each joint, we put a potentiometer. And so the hinge was actually the potentiometer. So when you would move part of the arm, the reading on that would change. So you'd get a different voltage out of it. And so now in lab, Justin Summer, one of the ME techs that works in the ME department, he took my design and then made a much fancier version of it. It's machined out of aluminum. So he spent a lot of time designing the arms that are in the lab and trying to make them as robust as possible. The arms have survived very well. The potentiometers and the wires attached to them, not so much, but we'll probably work on a new version eventually. So that what you're seeing for the transparent one, the one which if I now go in here and drag some of these around, the potentiometer sliders that I've put in here, you're moving the joystick with those sliders. And these are going to be the potentiometer values that we can read out and then hopefully write the correct value to the servo arm. And you can control each joint. You can see the elbow, the wrist, and also the grippers. So now that we've looked at that, if we go back to the documentation page, there's a way to create Mechaiddqd Servos, which are effectively just servo, like the same functionality as servos, but in the simulator. And so we need, instead of creating servos, well, even before that, instead of creating a connection to the Arduino, we need to create a connection to Mechaiddqd. And so we do that just like we did with the, what did I call it? Motor ball? It was like Powerball at one point. I was like, that's too lottery. So we can create a new Mechaiddqd connection. So instead of calling Arduino, I call Mechaiddqd. And then instead of creating a servo object, I want to create a Mechaiddqd Servo object. And if I do this now, the one thing I'm going to change, and part of what I had to cut in with another piece, like another video, is I was trying to use D3. The servo arm, which I will now go down to this schematic that I made, the servo arm uses D5, D6, D9, D10, and D11. And so each one of these joints has a potentiometer on the joystick, which, one second, let me bring Mechaiddqd back up. All right, I'm back. So each one of these has a potentiometer that goes to an analog pin. And so on the waist, it's connected to A0. And so if we were to read A0 while I drag this around, we would actually see, and we can do that. Let's do that. Let's not write anything to the servo yet. So let's just read A0. And I'm not printing it out. Good job, Banish. Good job. Excellent demo. All right, let's try running that again. All right, so it's printing out the value, and you can see that it matches with the slider value as I drag it around. All right, slightly better demo. Now that we've got the potentiometer value, we can write that to the servo. And so instead of that servo object, we have a Mechaiddqd Servo object. And we're going to change this from D3 to D5. And in here, we're going to use the same right position. We don't have to change anything. We just have to create, again, instead, a Mechaiddqd Servo object instead of a servo object. So now if we write this, we should see the servo follow the motion, or at least do something when we write the potentiometer value divided by 5 to the servo. So let's give it a try. And you can see kind of the arm interacting with the environment. We need to write other values to the other servos, because right now they'd be powered, but they'd probably be receiving some sort of noise, and it stopped because the program stopped. But this is, and if we wanted to, let's add in a second one. Let's do the worst possible way we can do it and say servo object 2 is equal to Mechaiddqd Servo D6. And then in here, we'll grab a second potentiometer value. A much better way to do this would be using arrays. Hint, hint. Arduino object. Nope. Yeah. Arduino. Well, it's not an Arduino object anymore. It's a Mechaiddqd object. Read voltage. And we'll pass it A1 in this case. If I can type. And we'll throw semicolons so we don't have to see all that. And then we will write servo object 2 pot 2 divided by 5. So we're now hopefully going to be able to control 2. I'm pretty sure the shoulder, when we set these up, not all of the servo arms were assembled exactly the same. When you're putting them together, you kind of have to like eyeball, is this exactly 90 degrees? And the servos are not perfectly uniform between each other. And the potentiometers are even harder to make sure they're right in the dead center while you're assembling them. So there's variability between what you get in this and what you get in lab. And in fact, each one of the joysticks and each one of the servo arms in the lab will give you slightly different performance and different like values. A perfect 90-degree setting for all of them would in fact be pointing to a slightly different spot each time. So that's enough of that. Let's do this. So now we have the waist, which we can rotate around, and if we control the shoulder, you can see that it's actually mirrored. And this is what it is for the vast majority of servo arm and joystick combinations in the lab. You get almost a perfect mirroring of motion there. And so the big challenge for task number 4, I kind of already did task number 3, right? The waist is an easy one because it matches up perfectly. But the shoulder, elbow, wrist, and gripper are different cases. And so coming up with the correct function to go from mapping on one, or mapping the potentiometer values onto the servo positions. Good times. I think this is fun. If you don't, you're mean. You can make me cry. Okay, that's all I get. See you later.